AP Statistics, Unit 1, Topic number 5, the 5-number summary and box plots. This is a continuation, like I said in class, it's a continuation of the numerical summarization for data, or it's the summarization for numerical data sets. So this is like part 2 from the previous one, so I couldn't include them in one single day's topic. And even then, I didn't really get to finish in class. So we had some good discussion on how to calculate 5-number summary, but I didn't really get a good amount of time on box plots. So 5th period, I think I rushed through it really quick, and I gave a kind of the shell of a box plot, but I didn't get to finish it. So I'll just do this one all over again, number 4, and how to cover box plots. So for this data, I know I read it for one of my class periods, but probably not for both. So what we have here is data for each of the 50 United States plus District of Columbia, DC, separate from the United States. A lot of the times, census data will add a 51st region like that, DC on its own. So there are 51 values here. So if that's 51 values, and that's 3 left over here, we're left with 48 for these first 4 rows. So that's 48. I notice that that's 4 rows. It's 12 all the way across. So 12, 24, 36, 48, 49, 50, 51 is how that works. And I need to know the layout of exactly how many numbers in each whatever. So I need to know that when calculating the 5-number summary. A box plot is a way to visualize the 5-number summary. So along an x-axis, it's going to tell you where the minimum, maximum, Q1, Q2, Q3 are. So I'll go through it. So first off, we'll just look at the numbers, the straight numbers, and then we're just going to go ahead and calculate the 5-number summary. I'm going to do that to the side. We have a minimum, we have a Q1, Q2, Q3, and a maximum. So don't mind the handwriting. Those are Q's. That's a Q2. Lowercase m is for minimum. Uppercase m is for maximum. So obviously minimum is 17. They have it ordered. And then 47 would be the maximum. So then I have to find the median. And the median for 51 data values. That's a nice number. I like that because there is a middle value. And the middle value, if you remember in class, how to find the middle value? You take the sample size, add 1, you divide it by 2, and it's going to give you the position of the median. So 51 plus 1 is 52, divided by 2 is 26. I want the 26th value. So the 26th value, these are 12, these are 24, 25, 26. There's my median. And it just so happens that the 26th value is equal to 26. That's a coincidence. That could have been anything, any number. So our median is 26. And I want to be mindful of where that median is at. Keep in mind where it's at. And because it's odd, now you completely delete the median to find Q1 and Q2. And what you do is you take all the values to the left of it as a lower half, all the values to the right of it as an upper half, and then you find the median of each of those halves. And median of the lower half is Q1, median of the upper half is Q3, like we saw in class. So then, how many values do I have to the left of 26? Should be 25, right? 25 and 25 would be 50 plus 1 more. So it's 25 to the left. So then 25 is an odd number, so there's another middle number, and it's number 13. 25 plus 1 is 26, divided by 2 is 13. So on the 13th, the first row contains 12. The very first one in the next row is number 13. Is how that works. So then I got to figure this out, because now we're starting at an offset value. That's 2 here, so that's 10, 11, 12, 13 then. So here I've counted the 13th value for both halves. So then that's my Q1 is 24. My Q3 is 30. And if you're not sure where I got those from, just literally count 13 values. And that's going to be the middle for each of those halves. Okay, so then how do I start my box plot? Box plot, if you look above, you would calculate the values in the 5-number summary, check mark. Draw a horizontal line and add an appropriate scale and label. X-axis, so literally draw an X-axis. So we'll draw an X-axis, give an appropriate scale. I notice the minimum is 17. I'll start at 15, and I'll go by 5s, all the way finishing up to 50 because I see 47 is the largest. So by 5s, 20, 25, 30, 35, 40, 45, and then 50. Then we'll mark them. 20. I'll mark 30 because I'm lazy. 40 again because I'm lazy. 50 here because I'm lazy. We got the basic idea. So then what you do is you mark each of these with a dot, a single dot. 17, 24, 26, somewhere around here, 30, and then 47, all the way up over here somewhere. And in a traditional box and whiskers display, where we don't really show outliers, because it says here showing outliers if there's any. So I'm gonna have to modify this for outliers. So here's how we get this done, not considering outliers. So if you're just drawing a good old-fashioned box and whiskers display, you're gonna draw the whiskers. So between the minimum and Q1, you draw a straight horizontal line connecting the two. Same thing for Q3 and the maximum. Straight horizontal line between those. And there we go. I don't know if would it kill me to draw like just one straight line. So those lines look ugly. But anyway, between Q1 and Q3, you draw a rectangle. And it's going to give you a good visual for what that middle 50% looks like. And if you remember, the distance between those two values, the middle 50%, is the IQR. So I'm just marking stuff you wouldn't normally mark anyway. It's just instructive. And then we drew another dot in there, right in between Q1 and Q3, which represents Q2. You're going to draw another vertical bar. And that little vertical bar in the middle tells you where the median is at. That's the middle of the distribution. So then you should kind of see the left whisker is going to be shorter, way shorter than the right whisker. And that kind of clues you in on what type of shape we're expecting for the data set. Even though we can't see the entire thing, I can see these 5 numbers, and I notice that the distance out between here and here, the upper quartile versus the lower quartile, the upper quartile is much more stretched out than the lower quartile. So I kind of guess that there's skewness going on, and I would probably guess there's right skewness. So if it's not skewed though, maybe there's an outlier or two. So it's possible that we have upper outliers then. So we don't really know for sure if it's skewness or if it's because there's outliers, right? So it could be outliers, or it could just be skewness. So that's not something I know for sure, but if I were to guess, it's one of those two things. That's the reason for the stretched out right whisker. Okay, so then they want me to show outliers if I can. So we need to see if we can actually find out if there's any outliers, and the way to do it is the way we did it in class. You find the IQR. IQR is Q3 minus Q1, 30 minus 24. So 30 minus 24 is 6. See if I do that right. So 30 minus 24 is 6. IQR is 6. I want 1.5 times that value, which would be 9. And the 9 is going to get subtracted from the minimum. So if you remember, the lower end point is not the minimum, sorry, Q1. So 24 minus 1.5 times 6. The upper end point is Q3, which in this case is 30, plus 1.5 times IQR, which is 6. So it's Q1 minus 1.5 IQR to the left, Q3 plus 1.5 IQR to the right. And then we carry that out. So 1.5 times 6 is 9, from what I understand. So half of 6 is 3, so you want 1.5, so 6 plus 3 is 9. 9 subtracted from 24 is 15. So anything below 15 is an outlier. Or 30 plus 9, 39. Anything above 39 is an outlier. So then the question is, do we have outliers? So I go back to the data. Anything below 15 is an outlier. No outliers to the left, because the smallest value is 17. Anything lower than 15 would have been an outlier, right? So no left outliers for sure. However, the upper range stops at 39. We have an outlier, 47. So then what do? We erase that whisker, stop it at the first non-outlier, or the last non-outlier, 38, which is here. And then you mark any other outliers or any other values to the outside of that, 47 for example, as an outlier. And I'll mark it as a asterisk. You can mark it as another dot. You can mark it with maybe like a big circle. You can mark it with a big star if you want. Mark it with whatever you want, like a heart. which my hearts are kind of ugly looking. So either way, I'll just put an asterisk. And that should work. That's 47. So any outliers you have, you mark them with asterisks, or you mark them any way, shape, or form that it's obvious that one's an outlier. So then, I could start talking about shape again. What you do is you disregard that outlier and you look at the box and whiskers display we have there. As far as I can tell, fairly symmetric, plus an outlier. That right whisker looks about the same as the other whisker. And it really depends on my scale, and it wasn't really perfect, so maybe, maybe not. So you can't really tell what the shape looks like with a box plot because you're only seeing 5 numbers. You're only seeing the location of 5 different numbers. You're not really seeing everything, whether or not there's a gap, whether or not there's a cluster or clusters, that sort of thing. So we don't really know. But that's there. So that's it for a box and whiskers display. And I don't know if they're going to ask me for anything else, and it doesn't look like they will. So that's basically it for this particular handout. So now you know how to draw a box and whiskers display. You're going to want to practice that for the homework I'm going to have set for Thursday. So we'll stop it here.